Welcome to more on series and sequences. We're going to learn some new stuff and at the same time do some review. So when do you use the recursive formula? Take a look at the top. These formulas are on your formula sheet. They are called recursive. We don't use them very often, but we do use them. So for number one, we're going to jump right in and start using the formulas. It says write the first four terms of the sequence if a sub 1 is equal to -4 and a sub n is equal to a sub n minus 1 plus 5. So a sub n, any term, equals the term before it plus 5. So now we're going to get an answer for our a sub n and then bring it back into our new problem. So first time through, we're given that a sub 1 is -4. We're going to take that -4 and put it back in. -4 plus 5 gives me 1. We're going to take the previous term, which is 1, put it back in. 1 plus 5 is 6. We're going to take the previous term, 6, and put it back in. And 6 plus 5 is 11. This is called recursive. You got to look for the notation. Sometimes they'll say it and sometimes they won't. In problem number 2, they do state that it is recursive. What would be the recursive formula for the sequence? We have -5, 2, and 9. As soon as they say recursive, we want to write down the recursive formula. And all we have to do is figure out what D is. The difference, the common difference, is 7. So there is our formula. Let's take a look at number 3. It says given that a sub 1 is 4 and a sub n is equal to 4 times a sub n minus 1. The indication that this is recursive because we see that n minus 1 as a subscript. Find a sub 3. So here we go. A sub n is any term equals 4 times the term before it. So let's set up a chart. First time through, we're given that it is 4. Okay. Second time through, we're going to take the previous answer, which is 4, plug it back in. 4 times 4, 16. Next time through, when n is equal to 3, we're going to plug in the previous term, which is 16, multiply by 4, and we get 64. So this is recursive. Take a look at your formula sheet that you were given. Where the arrows are, these are your recursive formulas. Anytime you see recursive or know you're working with recursive, these are the formulas you're going to write down for arithmetic and geometric. All right, let's just get back into doing some practice. So find the 38th term of the arithmetic sequence if a sub 1 is 7 and d is equal to 5. So what are we looking for? A sub 38. We definitely write our general equation for arithmetic, and here you are. We're going to plug in our knowns. Once we plug in our knowns, this is what we get. We always simplify. 38 minus 1, 37 times 5 plus 7 is 192. Question number 2 says 72 is the blank term of the arithmetic sequence. What we know is arithmetic sequence. We just need to find in this time the term number. What place is it in the lineup? So we always start with our general equation, and here it is. We're going to plug in what we know. But what we know is that D is 7 and a sub 1 is -5. We know the outcome is 72, so we put a sub n, the value is 72. And from here, we simplify. We distribute 7 times n and 7 times -1. We solve for n, and we find out that n is equal to 12. So in the 12th location, the value is 72. Go back through it so you can see it. There you go, 125 over 32. Number 5, find the 18th term of the geometric sequence. You can push pause and try it and then see if you get the answer correct. The answer is -393, 216. 393,000, -393,216. Number 6, find the missing terms of the geometric sequence. Push pause and see if you can get this. All right, here we go with our setup. Solving for r. Take the cube root of both sides. We find that r is -5. So we're multiplying each thing by -5. And voila. Practice. So for the next 6 problems, go ahead and write down these answers, 1 through 6. I have an asterisk beside the ones that you probably want to do without a formula. However, it's up to you. When you write these down, we're going to go to 6 questions, and you will try those 6 questions, write them and keep them in your notes, and let me see if you came up with the correct answers. Here we go. Number 1 and number 2. Alrighty. Number 3, 4, 5, and 6. All right. Our last thing with series and sequences is infinite geometric series. So infinite geometric series are going to be the ones where we go to infinity. So divergent series have an infinite sum. All arithmetic series are divergent. Convergent series have a finite sum. Some geometric series are convergent. Here's the key. The absolute value of r must be less than 1, then the series converges. Okay? And when we talk about diverge and converge, if we were to start adding up the numbers, if they diverge, they're just going to keep getting larger and larger, or more negative and more negative. If it's convergent and we add them up, it's going to start to get close to a certain number. Like it may get close to 2, and it'll be 1.99, and the next one will be 1.999, and the next one will be 1.99999. So as we add them up, it just seems like it's getting closer to a particular number. Alrighty, so we'll find S sub infinity on your formula sheet. A few things we're going to have to do is find r. It needs to be between -1 and 1. If so, continue to step 2. We find what a sub 1 is, and we use the formula. Here we go. Number 1, you're given 6 plus 4 plus 8/3 plus ... So what is a sub 1? It is 6. I'm going to put it in the formula. What's r? Is 2/3. Is 2/3 less than 1? Yes. So it definitely meets our criteria. So we're going to put it in the formula. 6 divided by 1 minus r, which is 2/3. 1 minus 2/3 is 1/3, and 6 divided by 1/3, multiply 6 by the reciprocal, and it's 6 times 3, which is 18. Take a look at number 2. This is your summation key. First time through, you get a sub 1 is equal to 4. R is what's in parentheses. It follows the formula from your formula sheet, which is 1/8. We go ahead and put this into the formula. 4 divided by 1 minus 1/8, and it's 32/7. So no matter how many times, if we were to go from n equals 1 to n equals 100, it's going to get very close to 32/7. If we do it to 1,000, 1 to 1,000, it's going to get very close to 32/7. And this is your infinite geometric series.